Hello, today we're going to learn about end behavior in rational functions. Now if we look at this function, 1 over x, as x goes to infinity and negative infinity, so as we move to the right and as we move to the left, what does f of x, what does the y value get very, very close to? And that answer is 0. To the right it gets to 0, and to the left it gets to 0. Now another way that we can write this is the limit as x goes to positive and negative infinity of f of x will equal 0. Alright, so if we look at this, we can check this in the tables also. So if you graph this in your calculator, you can look at the tables and see that the tables also get very, very close to 0 as you get your x values get very, very positive or very, very negative. Now if we look at this graph, let's try to figure out what this is. We can do it on our calculator, or we can divide it out. And this would be 2x plus 4, subtract it out, so that'd be negative 1. So this would be y equals 2 minus 1 over x plus 2. So if I sketch this real quick, I'll go 2 to the left, 2 up, and I'll draw my lines. And so this would, instead of being like this, it would kind of come like so. So here, as we go to positive infinity or negative infinity, my f of x is going to get closer and closer to 2 on both sides. So this right side is going to go to 2, on the left side is going to go towards 2. Now, if I looked at 1 over x squared, that is this function, that's going to get closer and closer to 0. If I looked at 1 over x to the third, that's also going to go towards 0. So these two are 0. This one was 0, so 1 over x squared, 1 over x to the third, all those go to 0. So 1 over x to the n, you might make a guess that as x goes to positive and negative infinity, y is always going to go towards 0. Now what about this? If I put a 3 above x squared, all that's going to do is pull it away from the axis, so it'll look more like this. However, as we go further and further to the left and further to the right, it's still going to go towards 0. Or negative, if this is negative 8, it's going to be down here. It's still going to go towards 0. So it doesn't matter what's in the numerator, as long as there's not an x there, I guess. As long as it's a constant over x to some value, this is always going to go towards 0. That's more general, I guess, than this first one we went through. Now we can use that information to determine the end behavior of any rational function. There's a little bit of work involved, but it'll make sense after we do a couple. Keep in mind it gets a little confusing at first, so we broke it down into a couple steps. The first thing we do is multiply the numerator and denominator by 1 over x to the n, where n is the degree of the denominator. The degree of this denominator is 1, so we're going to multiply each of these terms by 1 over x. So this is 3x over x minus 4 over x all over x divided by x plus 7 over x. Now this becomes 3, because x divided by x cancels out, minus 4 over x. And this becomes 1 plus 7 over x. Now since we get it to this point, let's think about when x goes to positive and negative infinity, what happens to each of these sections? As it goes to infinity, this section is going to go towards 0, and this section is going to go towards 0. So f of x is going to go towards 3 minus 0, I should say, over 1 plus 0, which is just 3 over 1, which is 3. So as x goes to positive and negative infinity, my f of x is going to go towards 3 in this function. Let's look at this one. We take x to the fourth, the largest exponent in the denominator, and divide it by each of these. So 3x to the third over x to the fourth minus 7x over x to the fourth plus 1 over x to the fourth, all divided by 5x to the fourth over x to the fourth minus 3x over x to the fourth, which is going to go to, this would be 3 over x, this would be 7 over x to the third, plus 1 over x to the fourth, all over, this would be 5 minus 3 over x to the third. Now as x goes to positive negative infinity, this would turn to 0, 0, 0, so 0 minus 0 plus 0, all over 5 minus 0, 0 over 5 is 0. So as x goes to positive negative infinity, this function goes towards 0. Let's try this one. X squared is the largest degree in the denominator, so 6x squared over x squared. Now we divide the denominator the same way. Oops. So I have 6 minus 5 over x plus 1 over x squared, all over 3 plus 2 over x. What happens here, here, and here? They'll all go to 0, leaving this as 6 over 3, which equals 2. So as x goes to positive negative infinity, f of x is going to go towards 2. Now take a second and try this one and see what you get. Alright, hopefully you're done. This is going to go to 8x over x squared minus 4 over x squared, all over 7 over x squared minus 5x squared over x squared. So that's going to bring us to 8 over x minus 4 over x squared divided by 7 over x squared minus 5. So all of these go to 0. So 0, 0, 0, 0 over negative 5 is going to be 0. Try this one. Hopefully you paused your video and you're back. This one's a little tricky. It'd be x to the third over x minus 7x squared over x divided by x over x plus 4 over x, which brings us to x squared minus 7 all over 1 plus 4 over x. Oh, this would be 7x. So what we do here is, if I put in infinity, this would go towards x squared minus 7x. This would go towards infinity. So that would be 0. So there would just be a 1 in the denominator. So it would go towards where x squared minus 7x goes to when there's an infinite number in for x. Well, x squared minus 7x, that's a parabola, and it's facing up on both sides. So as it goes to infinity on the right side, and the left side is going to go towards infinity. All right. Hopefully that's enough to get you through your homework. Good luck.